deep learning, machine learning and compressed sensing, natural language processing, and robotics. Thank you, sir, for joining.
Thank you. Thank you.
And the next session chair is Dr. Anil Kumar. Dr. Anil Kumar has around 15 years of experience in teaching. He is currently working as an associate professor at Purnima Institute of Engineering and Technology, Jaipur. Earlier, he had worked at Sri Sathya Sai University of Medical Sciences, Sehore, MP, and JVMGRR Institute of Computer Applications, Charki Gadri, Haryana. He has received his PhD degree in the field of computer science and engineering in 2019. He completed his MTech degree with distinction in computer science and engineering from Guru Jambeshwar University, Hisar in 2005. He completed his BE in computer science and engineering from RKDF Institute of Science and Technology, Bhopal in 2001. His key areas of interest are cybersecurity, penetration testing, information security, and cryptography. He has been a resource person in various FTPs, workshops, guest lectures, and seminars. He has published 15 research papers in various reputed national and international journals and conferences. He has 3 full published patents and 1 copyright under his name. Dr. Anil Kumar has successfully published 2 edited books. He is life member of ISC and ISTE and fellow member of CSI and ISTE. Thank you, sir, for joining. So these will be the presentations for this session, total 6 presentations, and the speakers are requested to follow the 10-minute timeline, out of which around 6 or 7 minutes will be for presentation and 3 or 4 minutes will be for the questions from session chairs. Okay.
Yes, so I think let's start with paper title 6.
Sir, may I request all the session chairs and participants to turn on the video for a group photo, then we'll be starting.
Okay.
Yes, sir. Thank you. It is done. So we'll start the presentations. First presentation will be from paper ID 6, Mr. Mangesh Ramai Kose.
Good afternoon, everyone. So first of all, share my screen. Is it visible, sir?
Yes.
It is visible. Can you please turn on the slideshow? Okay, you can start.
Okay. First of all, good afternoon, everyone. This is Mangesh Kose, and I am here to present my paper, which is titled as Comparative Analysis of Node-Dependent and Independent Graph Matrix for Brain Connectivity Network. So outline of my presentation includes background, literature survey, methodology, results, conclusion, and references. So before I start explaining what is brain connectivity network and graph matrices, I would like to give some overview about the human brain. The human brain is made up of complex networks of neurons which are interconnected using synapses. It controls the physical as well as cognitive activities performed by a person. There are various disorders which can affect the normal behavior of a human brain. These disorders are complex and caused due to various different factors, which make it more complicated to diagnose. The traditional approach of human brain analysis, which is nothing but extracting features from recording EEG signals and extracting features from individual channel and then performing classification. It ignores the fact that the human brain is consist of discrete regions of independent brain regions which are interconnected to perform some activities. So an approach considering these discrete regions and their interconnection is needed to perform in-depth analysis of human brain functionality. So the term brain connectivity network is an advanced approach to model the connectivity among discrete brain regions, which is modeled as n equals to VE, that is network n, which is consists of set of vertices and set of edges. Here in our study, we have used EEG channel as a neuroimaging tool to model the brain connectivity network. So the graph theory is a valuable framework to study organization of functional connections in the brain. Graph theory-based network analysis reveals meaningful information about the topological architecture of a human brain network, which is very important for the in-depth analysis of a human brain. So these are some papers that I have referred for this particular study. I would not explain them in detail due to this time limitations. So the problem description. So as graph theory is a valuable framework to study the organization of functional connections in the brain. However, its use for comparing topologies of network having different number of nodes have some limitations. That is, the number of nodes in the network affects the value of local graph measures used to analyze. The proper selection of graph theory-based measure is very important to get the unbiased results. So the presented study compares the two categories of graph measures, that is the measures which are dependent on the number of nodes, and the second, the measures which are independent on the number of nodes, which was abbreviated as INN. So the comparison is performed to evaluate their suitability for analysis of brain connectivity network topologies having different number of nodes. This is the process flow diagram of that proposed methodology. First, EEG signal recording and reprocessing, which includes filtration. After that, construction of brain connectivity network. Then extraction of INN as well as GNN graph matrices from each of the brain connectivity network corresponding to 16 channel and 19 channel EEG. After that, calculating the similarity and distance measure to find the variability in the particular type of category of graph matrices. Then comparison and selection of metrics. So the methodology has been applied on two data sets having different number of channels. One is a 16 channel EEG data set corresponding to schizophrenia and healthy subjects, which is 128 Hz sampling frequency and having length of 1 minute recording. The data set 2 is a 19 channel EEG data set corresponding to the same schizophrenia and healthy data set, healthy subjects, which is also 128 Hz sampling frequency and 15 minutes of recording. So what is a brain connectivity network? The connectivity or relation between different brain regions can be modeled as a brain connectivity network or graph using the equation G equals to VE, where nodes V interconnected to set of edges E. The brain connectivity network construction is a three-step process, which includes first one is a node definition, next is edge definition, then link establishment. So as you know that the node should represent the different brain functional regions. In the case of brain connectivity network, the simplest method is to treat each measurement point as a separate node. Hence, in the case of EEG-based brain connectivity network, the node is nothing but the electrode which is used to record EEG, as represented in the 16 channel, the node representation of 16 channel EEG. The next is the edge definition. In the EEG-based brain connectivity network, edge represents the correlation between different regions of brains. The correlation can be measured using various different methods. Here we have used correlation coefficient as a similarity measure or correlation measure to find the similarity or correlation among different brain regions. The mathematical equation is given in this, where x of n and y of n considers the signal corresponding to the channel 1 and channel 2, for example. Here phi x and phi y corresponds to the mean of signal x and signal y respectively. Here tau x and tau y corresponds to the standard deviation of signal x and signal y corresponding respectively. Then link establishment. The study considered the unweighted graph for extracting graph-based measures. Hence, the corresponding adjacency matrix will contain either 0 or 1 value, where value 1 represents the presence of connection between the nodes and value 0 represents the absence of connection. As shown in the figure, the white boxes represents the presence of connection and black boxes represents the absence of connection. The presence or absence of connection is dependent on the threshold value. The threshold value is to be selected carefully, as the less the value of threshold, the more, or we can say more dense network will be constructed, where the connectivity or number of connections which will not be as useful. Means it will actually add some extra overhead to calculate the features, which will not as much useful as it represents. Hence, the proper selection of threshold is needed. Here, we have considered threshold value of 0.4 of the correlation value, which is about 40% of correlation value. Then graph theory based measure extraction. So the graph matrices are used for quantitative analysis of brain connectivity network. Here, two categories of graph matrices are extracted from Bayesian in order to identify their suitability for applications where the number of nodes in the network are not same. So as I already told, the two categories of graph matrices are DNN and INN. So DNN matrix represents or characterizes each node individually. Hence, the change in the number of nodes in the network affects its value. The DNN matrix utilized in this study include node degree, betweenness centrality, closeness centrality, participation coefficients, and within model degree. Whereas INN matrix represents the whole or describes whole network in a single measure. The INN matrix utilized in the study are characteristics path length, modularity, link density, and network transitivity. Then after that, after extracting the INN and DNN based graph matrices from each brain connectivity network, the similarity and difference measures are calculated for each category of graph matrices corresponding to 16 channel and 19 channel EEG brain connectivity network. The category of features having minimum value corresponding to distance measure and maximum value corresponding to similarity measure will be considered suitable for analyzing the brain connectivity network with variable number of nodes. As the category of features shows null or less effect due to number of nodes in the network. The similarity and distance measure utilized in the study includes correlation coefficient, Euclidean distance, city block measures, mean square error, and maximum error. This slide represents their corresponding mathematical expressions. So the results and discussion. The study focused on comparison of DNN and INN features extracted from EEG-based brain connectivity network by calculating the similarity and different measures. The idea behind calculation of similarity and distance measure is to identify the variation in the INN and DNN matrices due to the change in the number of nodes. If the difference and similarity value is minimum and maximum respectively for the particular type of metric, then that category of matrix will be suitable for the analysis of brain connectivity network with different number of nodes. So the particular table represents the value for various difference and similarity measure. Here correlation is the similarity measure, which has maximum value corresponding to the INN matrix, whereas all the from row 2 to rows 5 represents the distance measure, where INN has a minimum value corresponding as compared to the values in the DNN matrix. Conclusion. The presented study provides a comparative analysis of the two categories graph matrix based features to identify its suitability for the analysis of brain connectivity network with different number of nodes. The network is constructed using 16 channel and 19 channel EEG signals from schizophrenia disease and healthy subjects. The variability of the features from 19 channel and 16 channel EEG are analyzed using distance and similarity measures. It has been observed that the INN graph matrices are not much affected by the variable nodes in the network. Hence, to compare the networks with a different number of nodes, the INN graph matrix must be extracted. These are the references. Thank you.
Any questions from session chairs?
Magnesh,
Just one.
why you are doing your study on means in graph domain? Why not in time domain? Means you are
Actually,
taking
sir.
Yes, you are taking EEG signals, na, and then you are representing them in form of graph or some adjacency matrix or something like that. So why you are doing that? Why not directly we can do that?
Okay, sir. As I have already explained in the previous slides, the traditional approach means we record EEG signal corresponding to means using EEG channels, and we extract features from separate channel and then combine those features and then perform classification. So this approach of analyzing the brain functionality has some limitation. That, as we know, that human brain is consist of connection of neurons, which are divided into different lobes, we can say, or different regions, where each region is responsible for different activities. So while performing some cognitive or physical activity, the different regions are communicated to perform that particular activity. The traditional approach will not consider this what we can say, this structure of a brain, means it will not consider the discrete different regions and their interconnection. So these interconnection between different regions of brain can be modeled using brain connectivity network, which uses the EEG signal for calculating the brain connectivity network. So the whatever the changes are occurring in the particular different regions, or which regions are communicating at that particular point of time, it can be modeled using brain connectivity network. Hence, we can in-depth analyze that particular functionality of brain.
Okay.
Any other questions?
Dr. Markesh,
Yes,
could you please tell me how much time you have taken for each data recording for schizophrenia?
sir, these are the
Recording
public
time.
data.
How much time
Is of about
for the analysis? Huh? Hello.
sir. Hello.
How much time you have taken to collect the data?
Okay, sir. The data set is not collected by me. It is a public data set that I have been used. The data set,
That is okay,
first data set, the first data set is of 1 minute duration, and the second data set is of 15 minutes. 15 minutes duration.
But as per the standard protocol of any international journal, so it is recommended at least you have to take for 10 to 15 minutes data, because in 1 minute you cannot get a variability because your analysis of this particular correlation and all, so that will take so much of time. Sometimes is required half an hour data also, because you don't know, because it's a totally chaotic in nature EEG, and every time the signal is changing with respect to time.
Yes, sir.
That means when you are taking some sort of data, that is always in discrete in nature. Okay. So when the signal is discrete in nature, this 1 minute, as per my understanding, is very less time for taking the data analysis purposes. And second thing is that you have produced your result. Is it have you validated your result? Means what is the standard deviation and all of your data?
Standard deviation, yes, sir. I have calculated standard deviation, but I have not presented in this particular slides.
Yeah. What is the actual standard deviation of this particular two signals? Means whatever you are getting, suppose you are using some data set, there should be some data set should be have some standard deviation, and from where you are getting the data set, that should have been reliable. And so unless and until you don't know that okay, this data set are perfectly reliable, and also the standard deviation is very less, so you can use the data. So my question is, what is the standard deviation of the data?
So I can't remember this right now at this moment.
Okay. And what is the exact novelty of your work in one sentence?
So the novelty is the study is try to select the type of graph matrix which is used for the analysis of brain connectivity network having different number of nodes.
Okay. Thank you so much from my side.
Thank you.
Okay, next presentation, we paper ID 258, Durlav Jyoti.
Yes, share my screen.
Mangesh, please stop presenting. Okay.
Yes. Yes.
Okay, I'll start my presentation.
Yes, you can start.
So my screen visible.
It is visible. You can start.
Okay. Yeah, sure. So very good from everyone. Yeah, since I'm going to present here, so I'm going to stress using easy simple, and my paper ID is 258. So I'm Dudabjiri Brahma. Yeah. So moving on to the presentation. So we'll start with the background concepts. Let's simple introduction. Possibly I'll be skipping the literature survey now because of time constraint and all. We'll see the problem description, which is kind of my objectives, and we'll see the methodology, and then we'll come to the results and discussion, and we'll end with the conclusion of my work. So moving on to the background. So this essay is based on the assessment of visual stress from EG. So stress basically means it's more of, as per our understanding, is like the result of the different emotional behavior in human being. Thus, monitoring of stress is a kind of challenging task because we are dealing with the pre-waves, you know. So, and some studies suggest that biomedical signal like EZ is widely used in the diagnosis of mental health, and as it first presentation rates sampled, and then we have extracted a feature. Let's say we have extracted a feature one for both alpha. Let's take for an example alpha. We have taken feature one of alpha 5 hertz presentation rate and feature one of alpha 10 hertz presentation rate. We have put that into some hypothesis testing, and here we have used Wilcoxon sign test because the data are non-parametric, and it's a paid data. So as per as our study, we have found Wilcoxon sign test will be the beta. So we wanted to test on that. So this hypothesis testing with the test based on the probability value. If it is less than 0.05, then it will neglect. We should neglect the features. That is more than 5% chances that both the features are extracted from alpha 5 hertz and 10 hertz both might be similar, or we can say, and if yes, then it will, the feature will be selected based on the probability value, and then after that, that will term as the class 1 to alpha 5 hertz sample will be from feature 1 alpha 5 hertz and class 1, and the feature 1 alpha 5 alpha 10 hertz will be class 2, and will fed into machine learning classifier, and then we'll check, we'll analyze our output. Similar things done for beta also. So after that, what we'll check is like when we are presenting image to a participants at 5 hertz and 10 hertz, and we are checking for the particular band, alpha band, let's say alpha band, and we are extracted a feature one which is being passed through Wilcoxon sign test, and we are checking its output. If we are getting some accuracy, good amount of accuracy, that means both the samples
Correct.
are
Can you
that
please
means
speed
I'll
up
go
and
to
conclude? Can you please speed up and conclude?
yeah,
It
sure.
has already been 8 minutes.
Yeah, sure. So like that we'll get that information about the stresses being applied, and a person is being feeling stressed, something else. So these are the features that we have extracted. So I'll be just this slide already covered. So we have used logistic regression and linear as being test classified for our project, and we have selected that features that we have selected from the other results. So these are the results of Wilcoxon sign test. From here we can get that in alpha band, the beta band, alpha band, and almost all the features are being passed, and only the mean frequency we could select, and in the beta band we could select many of the features, and we can select skewness, band power, energy, and from the p-value test, and After these are some of the results of our loss segregation and linear SBM classifier. And here you can find, like, from here we can conclude it's like a beta band is able to give us a better result. That means beta band is mostly activated when higher stress is being given to that person, and compared to the alpha band. And from both the loss segregation and the SBM plus, both giving same amount of result as far as concerned. And in terms of the features, like energy and the band power combined gives us a better result, you can say. So going to the conclusion part, I'll conclude here is like, so like we are able to access stress, we are able to get the information of the stress, whether the person is stressed or not, based on this whole project that we have done. And yeah, and that means higher classification accuracy gives us some information about, by increasing the task level, we are able to get higher accuracy. That means the stress is being like assessed properly. So that's how I like to conclude my presentation here. The references I've used. And thank you.
Any questions from session chairs?
Durla?
Yes, sir.
I have two questions. One question is, have you compared your method with any published method?
Like comparing means like what I'm getting here.
Means you are comparing the logistic regression results and the SBM results. But is there any comparison with the published method? Any previously published method?
Actually, we did some literacy survey about the whole thing, and we wanted like we have seen that in some of the people that this using SBM classifier gives a better result. But here, what our intention is, like from the scratch, we will go and we'll come to some conclusion on that. That was our whole priority. Yeah.
No, that is actually for a paper, research paper. There should be comparison with the published method. Okay.
Yeah.
And
I mean, like, yes.
Okay, then second thing is that can you say something about this test, rank test? How this test work? Which taking features as an input?
Yes, see, like we have to sample. What this test will do, it will do some hypothesis testing based on the probability value. Like if there is it will check both the sample, whether both the sample are statistically significant or not based on the hypothesis result. If it's less than 5%, that means both the sample is statistically significant. If it's more than 5%, that means it's both there are no statistically significant, and we can design the sample. So that is what the PC understand.
Okay.
Yeah.
I would like to one question. The database, the dataset you have taken from physionet.org, right? Durla sir?
Yes.
Right. So it is an open source dataset. Have you taken any kind of data from somewhere else also? Have you tried?
No.
Only from this website you have taken.
Yes, only from this website we have taken the dataset. We have worked on it. Actually, our main aim was to access visual stress, so that's the reason we are checking for. Like we found this and we worked on it.
Like Amit sir has said that is there any comparison is already been done earlier, or you are trying this for the first time?
Yeah, like in this data set, I haven't found any paper or research like the exact way what we are doing. Like we haven't found any. So like yes, some of the papers that we have found, like they are doing some emotional stress level for getting the output, but this visual presentation rate, I haven't seen that. So might be this my first, or might I have missed some. But as far as our understanding, I think we did it.
Dullab,
Yes, sir.
I'm wondering that you are taking the signal from the parietal and the occipital lobe of the brain, and you have displayed, if I'm not wrong. So, have you gone through any literature that
Yes.
these two are directly related with stress-inducing factors? Means my question is that when
Actually, human.
about
Yeah. Sure.
the temporal or the central part of the brain, means only for us concentrated
Yes.
about the parietal and the occipital part of the brain. So it's
Yes.
quite surprising, but because most of the time when we are focusing about stress, some sort of results will come from the temporal regions also. So if you can add something in your study about the temporal zone for this EEG analysis, so it will be a good.
Yeah.
I hope you have taken data from the PhysioNet, that is the open source data analysis, this database. But I'll recommend you, if you can take the data from the live condition, from the subject, that will be more emphasized to,
yeah,
and it will be more fantastic about and give you the more specific about the logistic regression and the SVM technique to get the proper output rather than the online data set. Because again, I'm coming back to, I'm not full trust on the online database, but at this moment it is very tough to take the data from the real subject due to the ethical problem and all. But it will be a very good chance if you can take the data from the live condition from the human subjects, from the three different part of the brain, especially the frontoparietal, that is called. Apart from the parietal, if you can take the signal from the frontoparietal, that is called FP, and another one is the occipital and temporal. So temporal is very much important. And second thing is that there are especially 5 bands in the EEG waveform. You have concentrated about the delta, beta, and alpha. So it is basically alpha rhythm is basically associated for the sleep conditions. And so when somebody having the stress, so my concern is that, and that there is some controversy about the stress and the sleep. And so is the alpha is directly associated with the stress condition? Why not the theta? Because yeah, please.
Sir, may I answer, because I am a co-author of this paper, this manuscript. I am Jupiter Hazarika, working as assistant professor in NIT Silchar. Good evening, good afternoon, everyone. Regarding your queries, sir, I would like to add, the first thing is, because of this corona situation, it is very much, we have our instrument, but it is
Dr.
very
Jupitra?
difficult to get subjects at
Hello.
this moment
Dr.
of time.
Jupitra, is it possible?
Yes.
Can you switch on your video?
Actually, sir, I am at home right now.
Okay. No issue. Please
If you don't
continue.
mind.
Please continue.
Yes, sir. Okay, so regarding your first question, Sudeep sir, because of the corona situation in last 2 years, it was very difficult to get subjects. That was the main issue. And the second thing, regarding your query about frequency bands, there are many literature available which shows relationship between stress and alpha, stress and beta. Some of the literature we have included in this particular presentation also, but if means in later on in the later stage, definitely we will be interested to explore much about how different frequencies are connected to different cognitive activities of the brain. Particularly in this particular paper, we have collected data online, which was available online. And then we tried to analyze based on the literature that whether there is any relationship between alpha activity and beta activity, which are found to be associated with stress in many literature, available literature. So we tried to explore that mainly. And as per the results suggest in this particular paper, compared to alpha activity, it has shown that beta activity shows better classification accuracy with the increased stress. That was the ultimate conclusion we have received and we have presented here. Thank you, sir.
Okay. Thank you.
Thank you, sir.
Okay, the next presentation will be paper ID 327, Miss Nandini.
Thank you.
Thank you, everyone.
Hello, am I audible?
Yes, you are audible. You can please. Yes, you can start.
My paper is MISP-2022 EEG emotion recognition using convolution neural network. The flow of my presentation is introduction, background, literature survey, problem description, methodology, result discussion, conclusion, and references. We know that emotion recognition plays a crucial role in human-computer interactions, diagnosis and cure of diseases, which are generally caused because of trauma or prolonged diseases. The emotional impact can be observed through the speech variation, facial expressions, and physiological signals like EEG. The EEG recording of electrical activity. It is done from the start, so recorded waveform reflects the cortical electrical activity, which occurs because of the chemical changes which is occurring in the brain. The main frequencies of the human EEG waves are categorizing them as delta, theta, alpha, beta, and gamma band. So this electrical potential generated by an individual neuron is very small, and multiple neurons or thousands or maybe more than million neurons connect together in spatial orientation, and we get the EEG signal. Basically, EEG classification, emotion classification system consists of we are taking EEG signal, we are removing the artifacts. The artifacts generally are the eye blinks, muscle artifacts, and some other, we can say that sensor variations can be removed. Then feature extraction is done and classification. So these are the literature survey I have used. Some people have used power spectral density, differential entropy, adjacency matrix, but all of them have used the SEED4 dataset. These are the three main papers we have selected. As I'm finding the feature called differential entropy, I use this RN1 paper. I'm using separable convolution, which I found from exception, and the Wiley paper by MISP domain adversarial network, which is a recent paper I used for the comparison. The problem description, I had to develop a EEG emotion recognition model, which can identify the multi-class emotion. We have used 4 classes of the emotion to achieve the better accuracy than state-of-art techniques and to reduce the computational complexity. This was our aim of the work. We have used D4 dataset, SEED4 dataset, which is easily available on the internet. There are 4 emotions: happy, sad, fear, and neutral. In this, they are collected data from 15 subjects, 7 male and 8 females, 3 sessions, and there are 24 trials per session. Each session was conducted after 8 days or 15 days period. In one trial, participant watched one film clip, and his EEG signal along with the eye movements were collected by 62 channel neuroscan system. The feature extraction. The signal was downsampled to 200 at sampling rate, filtered, noise and other artifacts were removed, and the signal was taken between 1 to 75 Hertz. Then we, with the help of bandpass filter, we have filtered different 5 bands we have found out, and we have found the differential entropy. This differential entropy is the extension of the Shannon entropy. So we are finding the variance between the low frequency and the high frequency bands, and that is called a differential entropy. What are the features we have collected? We have collected, divided them, or we have formed a 2D map. Then this 2D map signal, what are the features we have generated that is applied to the CNN model? A depth-wise separable convolution layer was used. In depth-wise separable convolution layer, a kernel is applied to each individual channel separately. So we can find the spatial features from each channel, and the point-wise convolution was used to have the temporal correlations. So it can merge the feature maps. The accuracy obtained with the separable convolution, it is as good as with the normal CNN, but with lesser number of multiplications. So this is my CNN model. We are using a subject-dependent dataset is used in our experiment. We are selected a batch size of 32. The learning rate of Adam optimizer was 0.001 with beta 1 value 0.9 and beta 2 0.99. In this case, to find the accuracy, as other people are used, we are used stratified k-fold cross-validation, which maintain the same class ratio over the all k-folds as per the ratio in the dataset. We have selected the value of k as 10. This is the comparison what I done. In this case, if I see the first paper, SVM, support vector machine, and the emotion meter and another paper, the deep belief network, they are also using the differential entropy, and they are getting the accuracy of 56%, then 66%, and we have got with the separable convolution, separable depth by CNN, we are getting the accuracy of 72.8% with the standard deviation of 5.78. We have also compared our results with other state of papers, but these papers are using some different aspect. Where graph, we know that they are using adjacency matrix in graph convolution, domain adversarial network, where they are using the two different lobes of the brain to find the features. This is the graph what I'm getting from my results. We are getting the accuracy 2.2% more than the emotion meter. Maximum accuracy is obtained with the batch size of 32. As we increase the batch size, we observe that the accuracy keeps on decreasing because our total data is small and CNN requires large data to get the better accuracy because fine tuning should be done. If I increase my learning rate to 0.01, it is also observed that as proper learning is not done, accuracy is decreasing. After that, we have found the confusion matrix from which we have drawn the heat map. This heat map shows that the accuracy we are getting for the neutral and the sad is maximum, whereas fear and happy, the accuracy of our proposed model is less. But the overall accuracy we are getting is 72%. Results and discussion. Time required. What are the time we required for running an epoch? We got it 1 second, whereas with normal CNN, which I worked with, I got 2 seconds per epoch. But I use here Google Pro GPU, Google Colab GPU. The accuracy has increased because we have considered spatial correlation between the channels, and the cross-validation has helped us to fine-tune the activation function in the neural networks. So what is we can conclude? Differential entropy found on different frequency band is more useful as a spectral feature. There is a performance improvement because depth-wise convolution works on individual channels and point-wise convolution merges the feature map. Though the low value of standard deviation shows that model gives stable EEG emotion recognition. These are my references which are used in the comparison. Thank you. So, hello. Hello. Yeah.
The work is really fine.
Yeah.
I have 2 quick questions that I want to share with you. That the CNN model that you have designed in MATLAB?
No, so I'm working with Python because I'm using.
Okay. So you have worked in Python. Okay.
Yes,
so for this case, what is the maximum limit of the error that you found during the training phase?
Maximum error.
Yeah.
When we start with the epoch, as initially I got 0.13, 1.3, sir, at the starting of the CNN. I mean, when we are starting the epoch, sir, initial, as the number of epoch increases, it has reduced up to 0.3.
Okay. So maximum is how much?
1.7 I got, sir.
1.7.
Yeah.
And my second thing is that what is the basic application of your model? Means why
we should go for the
we are
emotional data
using this
recognition.
kind of technology?
Yes, sir,
Okay.
I'm agree.
Okay. Thank you.
Hello, Nandini.
Yes, sir.
In data set,
Yeah.
there are 4 classes, na?
Yes,
so
sir.
how many samples are there in each class?
How many samples? Sir, I showed in the screen, sir. In the testing, this heat map shows that there are around 40 samples. This is for the testing, sir, because we consider 20% of the 10 stakeholder validation. Means I can say that 10% data I have taken for testing, and for 10% data I'm showing the heat map.
So data set is balanced or unbalanced?
So it's balanced, sir.
Balanced. Huh?
Yeah.
So means
there are 24 trials, and what they're done in the initial trials means out of 24, last 2 will be used for the different classes, and remaining 16 are used for the 4 classes.
Have you tried to calculate the feature means metric like precision, recall, F1 score, AUC, all these things?
Actually, I have not put them in the slides here. Yes, I calculate.
And one more thing, that in slide number 4, na, if you go slide number 4, you can directly go.
Yes.
Some means a presentation you have to improve, na? Like see here in second point, delta, theta, alpha, beta, and gamma.
Yeah.
By means this gamma is in symbol,
Yeah.
by other than symbol. So that you should improve.
Okay.
Okay. Okay.
Next presentation, paper ID 361, Manoj Kumar Sen.
It is visible, sir?
Yes, it is visible. You can turn on slideshow.
Yeah, it's okay, sir?
Yes, please start.
Okay. Good afternoon, everyone. I'm Manoj Kumar Sen from the LNM Institute of Information Technology, Jaipur. I'm going to present my presentation of dynamic hand gesture recognition using M-YOLO CSRT and HGCNN for human-machine interaction. Here, the M-YOLO represent the modified YOLO algorithm, and CSRT represent the channel and spatial reliability tracking, and HGCNN is the proposed model, which is hand gestures convolution neural network. This is a table of content for the presentation that include the literature survey, proposed methodology, result and analysis part, and followed by conclusion, feature scope, and references. In the background, for the proper interaction between the human and machine, there are 3 main tasks: detection, tracking, and the classification. The detection means the selection of region of interest, and tracking means the detection of region of interest in consecutive frames. And classification model used for the classification and prediction the output class. So there is lots of technique methods available for detection, tracking, and classification, but they have some limitations. This is a literature survey part. In this first paper, he using the background subtraction technique for the object detection and Kalman filter for the tracking the person in video frames. He got the accuracy around 90%, but it is not suitable for the real-time application because the background subtraction techniques required lots of background images with no person, and Kalman filter uses the constant acceleration and constant velocity model. So it cannot give the good result in varying velocity application. In the second paper, he using the wide CBCR color segmentation model. to separate the skin part from the non-skin part, and morphological operation and the thinning operation to employ the get exact information for the resultant region of interest. But in this paper is using only the hand, not the complete body part, and it is only suitable for the static information, not for dynamic. Similarly, these two papers using the different techniques for the detection and tracking. The first paper using the 3-frame differencing and cam-shift and KLT tracking algorithms. As the cam-shift and tracking algorithm have some limitation, like the cam-shift algorithm is not suitable for the occlusion, and KLTs also suffer from the tracking point reduction as we going for the long tracking. And RCN model is using the 2000 region proposals. So there is required lots of training time to classify 2000 region proposal per image, and it takes around 47 seconds for each test images. And likewise, in the last paper, in this paper is using the faster RCNN model, which is much faster than the RCNN and fast RCNN, but it also requires some training time. So these are the few of the literature I include here, and rest of the literature I mentioned in the reference part. In the problem description, the first is to design the object detection robust object detection algorithm that can easily track the region of interest in all challenging conditions like illumination variation, shape variation, and occlusion. And the next target is to design a CNN model which is having minimum number of layers and less complex and highly accurate. This is the methodology for the proposed paper. And in this paper, I first detect the face and the mask it, and then remove it from the frame, and then detect the hand in the frame using the YOLO modified YOLO algorithm, and given to the for the tracking using CSRT. And after the tracking, we got some trajectory points, and after the trajectory, and by using after we doing the trajectory smoothing to smoothen the gesture. And then this act as an image, and we use the image classification here for the gesture classification model using HGCNN model. And if the output is required, if the required class is equal to predicted class, then we use for the some application like controller device, or we using some for gathering some information from the website or from the internet. And this is the first step is use the dataset labeling. So to create a data set, using the label IMG tool. In this label IMG tool, we using the YOLO. We first select the YOLO here, and then select the create rectangular box. And by using the rectangular blocks, we drag the rectangular blocks on the particular object that we want to create for the detection. So in the data set, I using the two classes. One is for face, and second is for hand. So what is the output of this the dataset labeling? So suppose in the first images he has the face and hand. So in it create a text file here. So 0 represent the face class, and 1 represent the 0 represent the hand class, and 1 represent the face class, and the rest of the 4 points are used represent the bounding box coordinates. So likewise, the second image he has a 2 hand here. So in this in the text part, he has a 2 0. So that image the 2 hand classes, and 1 face is represent the 1 face class, and this other is the bounding box coordinates. So likewise, we generate this type of data set. So I generate my own data set, because due to the COVID restriction, we don't go to outside from the college. So we generate my own data set in the college by using some PhD scholars and some of the data set I collect from the some of the images I collected from the internet. So that's why I prepare my data set of around 3,000 to 3,000 images in a folder. This is the proposed detection model. The YOLO V3 use the darknet V3 model for the backbone, but the YOLO algorithm is suffering from the fixed size constraint problem. Means if the
excuse me, please speed up and conclude. It is already 8 minutes.
Okay, sir, I'm concluded. So this is the proposed model in which I using the SPP layer to reduce the fixed size constraint problem, and residual unit to improve the feature sizes. So in this, as we look here, the output is having the hand in the yellow detection bounding box, but there is a loss of 2 to 3 prediction is there. So to remove these 2 to 3 prediction, by using the intersection over union. So by intersection over union, we select the threshold value about if the IOU is greater than 0.5 or 0.6, we can remove the non-unwanted detection bounding box, and we get the exact bounding box which is nearly around the ground truth. This is some sample video. If you permit me, then I show you. If you permit me. So if this is the old version of YOLO, there is some problem, or there is a detection in the detection. There is no proper detection of the hand. But in the my YOLO using, there is a proper detection of hand in all the region of frames of, and this is a 2-hand detection model. Okay. Next is the Csrt tracking. In the Csrt tracking, using the correlation filter, it is basically a ROI tracker that track the object nearby area to the last detection. If the correlation is maximum, it creates a bounding box there and update the position. And likewise, it detects the region of interest in the consecutive frames. This is the proposed classification model for. In this, I using the convolution and max pooling layer. For the feature learning, so there are the three pair of convolution and max pooling, and in the classification I using the 3 dense layer. There is a 128, 64, and 32. This is reduced down the feature part, and in the last I using the softmax layer for the predictions. This is the result and discussion part. In the result, is the first is a detection comparison table between the detection algorithms. I using the frame differencing technique, FCRNN and YOLO V3 for that first for comparison on my data set, and I using my algorithm for the detection. I get that my proposed model get the highest accuracy, and detection time is very small. It is around 34 milliseconds. And this is a comparison table for the different tracking algorithms. So I do my tracking algorithm on the 3 pre-trained algorithm like KLT, CamShift, and I do the CSRT here. So in the CSRT, we get the 100% of the tracking rate. And next is the comparison table for the different neural network for the proposed CNN model. I using the LeNet, Inspection V3, VGC16, and LXNet for my comparison with my proposed model, and that and I concluded that my proposed model had less number of layers and less highest training accuracy, and highest validation accuracy, and test accuracy. This is the graphical representation. And in the hardware part, I design a hardware model for the using the Raspberry Pi model, and I using the LAN cable for the LAN connectivity, and in a Thony IDLE for the programming, and webcam for the gesture recording, and speaker for the output. And this is the one of the application of my hardware. In this, I using a live gesture recorded by the using webcam, and this giving to the for the detection and tracking. If the output is there is 7. And this going for the gesture recognition SGCNN model, and then we predict a class like this is a 7. If the required class is equal to predicted class, this the music being played the speaker. So likewise, we use the different gesture for the different applications. So suppose for the medical reminder, for the for other news application. In the conclusion, we use the proposed detection model is robust and can also detect the targeted object of the small size. And tracking algorithm perform quite well in all the challenging scenario, like good illumination, low illumination, partial occlusion. And proposed CNN model is quite small, less complex, and having good accuracy. And it is the main part is it is easy to deploy on the Raspberry Pi, because other network like AlexNet, like having the number of deep network, it is very difficult to deploy on the Raspberry Pi. In the future scope, there are some other network available like RNN, CDCNN, LSTM can be used with my proposed model like SGCNN for the better result, and Csrt tracking can also be improved for in terms of accuracy and speed. These are the references part. Thank you.
Manoj,
Yes,
could you please let me know that the novelty of your work and actual application area?
So novelty is my detection algorithm, object detection algorithm, and the classification model. in the detection, because the previous YOLO, the old version of YOLO having the fixed size constraint problem. Because if suppose I make a data set on a fixed images, and if the object size changes, so from small to big and big to small like this, so there is some problem in detection. So that's why I using the SPP special pyramid pooling layer is here, so that remove the fixed size constraint problem, and we can easily detect the object in the shape variation and size variations. And the HGCNN model that I generated my own and compare with the other model, pre-trained model, AlexNet, LeNet, and VGG16 models. These are the two novelties.
What is the application area?
The application, I am working on a DST project, and DST project in the I am looking for elderly people for their indoor environment. That can help in their indoor environment. So by using their gesture, they can implement they can doing some tasks like to hear the current news, for the medicine reminder, and for the other applications like to operate some hardware.
So it is under the DST project.
Yes, sir.
Okay, thank you.
Thank you, sir.
Manoj?
Yes, sir.
Can you just briefly explain the step-by-step means about the hardware implementation?
So in the hardware implementation, first I design a Python programming for that. First of all, I using a Raspberry Pi for that, and in the Raspberry Pi there is a Thony ideally tool is available. On that tool, I'm making my program for the different application. Then I using the webcam for the recording the gesture, and in that I using some API tools available that can connect with my, suppose I'm working on the medicine reminder, so there is an API available for the Google Calendar. So I using the Google Calendar API for that model. And there is some other API models that are available for the news purpose and for the other hardware, other communication devices. So I using the API and to connect my output with that part.
So how much memory is required to install in Raspberry Pi for all these things?
So basically I am working on the 32-bit, but it is likewise it is hanging there. So I'm just shifting on the Raspberry Pi 4, which is 64-bit.
Okay, means memory is there, no? Means
yes, sir, yes, sir.
Yes. How much memory is there in your hardware, Raspberry Pi?
Sir, I am working on 32-bit.
No, memory is different, no? It is the you don't know what is the memory size of SD card?
Okay, okay. It is 8 GB, 16 GB, sir.
16 GB. Okay, I mean, so you are doing training on PyKit, or you are just only doing the testing in PyKit?
Sir, only testing. I am doing my programming on the Spider platform and Google Colab.
Means you are not using Raspberry Pi platform?
Yes, sir, I'm using Raspberry Pi, but I'm because there is a problem of training purpose, because lots of training. Suppose we use a GPU for the training, but in the Raspberry Pi there is a problem of GPU. So that's why I'm using the Google Colab for the training, and next the result is saved in the for TensorFlow Lite. For TensorFlow Lite, then I using in the Raspberry Pi.
Okay. Okay, thank you.
Thank you, sir.
Thank you very much.
So can I stop sharing my?
Yes, you can.
Thank you, sir.
Okay, next presentation, paper ID 391, Mrs. Aparna.
Sir, am I visible?
Yeah, it is visible. You please present your PPT.
Yes, sure. Okay. Good afternoon, respected chairs. I'm Aparna Menon. I'm a research scholar from Department of Electronics and Communication Engineering. So the title of this work that I've done is on band sharpening of multispectral remote sensing data using multi-resolution analysis. Okay, so these are the table of contents, which is just a short of how I'm going to be dealing with within the next few minutes background. It just gives a background on what the topic is, the literature survey, problem description, methodology, results and discussion, conclusion, and references. So to give a little background on this one, multispectral images. Multispectral images are basically images which are of the range of 3 to 15, which includes all the images which are of specific wavelength across the electromagnetic spectrum. So normally when we're considering for remote sensing application, it will be around 3 to 15. So it can include both in the visible range and northern and beyond the visible range, light range. So all these images are included in that. Now, about the multispectral images, the greater advantage of this one is that it almost has a spectral continuity. So because of that high spectral resolution, it has a greater spectral resolution than another image. But obviously it has a lower spectral resolution as the total energy is used on each and every spectrum. Now, to stark opposite of that is a panchromatic image. So that is also available when you are going for different satellites like Landsat 8, which I've considered for this part of the work. So panchromatic image is normally having a lower spectral resolution because it is just a single band with a wide bandwidth, and that bandwidth is since it is wide, it is having high SNR rate, and because of that, it is having a high spatial resolution. But since it is just a grayscale band, it will be having a lower spectral resolution. So the idea of this work is to combine these two images. So it's just a fusion of these two images so that we can have both the properties of the multispectral image and also the property of the panchromatic image, which is the high spectral resolution and also the high spatial resolution. So by combining these two, we can get an image with a multispectral image with a higher spatial resolution, which we can further use for different and various kind of remote sensing applications. This is my literature survey. So the first one, Dear Exam, which deals with two-step band sharpening method, and it says that the image fusion results which are obtained in application dependent. Next one is Palma et al. And it says that it differs, that the band sharpening or the quality of band sharpening, it differs with using different number of decomposition level, and that gives a better band sharpening quality. And also that band sharpening could affect the vegetation indices. There are different vegetation indices, and that can be affected by this, which is what Palma states. And then they are using a different hyperspectral image. In this case, it goes for pixel level fusion. It says that this pixel level kind of fusion has same efficiency as other kind of fusion algorithm and has a better accuracy and less data loss. Now, it's a whole lot of book, and this one says that that wavelength-based fusion gives a superior image quality. Okay, so now the problem description, as I have explained before. Fusion of a multispectral image having high resolution with panchromatic image at high spatial resolution. And obviously, so we are going to merge these two so that, and we're basically pan sharpening these two images. And also here, the Landsat 8 data is considered, and we are just focusing on a small area in the Coimbatore district, and with which we are working on. And only, even though the Landsat 8 data has different range of bands, we are for now considering just the two bands, blue band 3 and band 4. Band 2 is the blue band, band 3 is the green band, and band 4 is the red band, and band 8 is the panchromatic band with which we are going to merge with. So this is the basic methodology flow diagram. First, the multispectral images, which is here for this one is the RGB. RGB is converted to the HSI model. And the multi-resolution analysis is applied to the intensity. So the specifically intensity image just taken, and this is applied to both the intensity and panchromatic images. Now we are having fusion coefficients, approximation, and detail coefficients, and these two coefficients of both the intensity and the panchromatic images are used. And an inverse transform is applied, and to get the finally modified intensity image, which is applied back to the HSV model, and with which by inversing that again, by taking HSV to RGB model, we get the multispectral image. Now, to talk about this Landsat, specifically, multispectral images are having 30 resolution and panchromatic images are having 15 resolution. You can see a stark difference in latest. And it's when I say resolution, it is the spatial resolution that I mentioned here. And this is the range of dataset coordinates. And it is from the Coimbatore district, Tamil Nadu. Now, these are the metrics, which are the correlation coefficient metrics. Here you can see that even though most of these different wavelets are giving the similar values, we can see that Corflet, Simlet, and discrete Mayer are giving a better value or better correlation coefficient while calculating this fusion techniques for the band 2, band 3, and band 4. Now, for considering, and obviously, as we know, the correlation coefficient values are desired to be about the range of 1. So that is the most desirable value that we need to have. And the next one that we are going to have is the SD, standard deviation. And here, what it means is that data variation from the mean value. It shows the data variation from the mean value. But here we can see that those variations are almost same for those values. Even though we are just taking 2 decimal values, it can vary minutely with each of the DWT which have been applied, but it does not show a significant change. Now, the next one is a PSNR value, big signal to noise ratio value. Here also, here the higher value is always desirable. And here also we can say that R is having a higher value when compared to the other DWT methods which are applied. Now, RMSE value, root mean square value, here you can see that almost all the values are same, all the results are giving the same values for this one. Next one is the spectral angular mapping, which actually maps the spectral angle between these two images, or what is the difference, or maybe these two vectors are being considered. So here a lesser value is almost desirable. And so while considering the lesser value, we can see the conflict is having a lesser value, spectral angle, lesser spectral angle, while considering with the other methods. Now here we are having ERGA's error relative global admission in day synthesized. And here also a lesser value, it shows the spectral similarity, the change in errors in spectral similarity. So a lesser value is always desirable, and Corflet is found to have a lesser value here. So this is the basic conclusion. Corflet, Simlet, and discrete Mayer are having higher value of correlation coefficient. For this band 2, band 3, and band 4, these are the value 0.99, 0.98, and 0.98. HAR has the highest PSNR value, 27.09, 25.56, and 25.6 for B2, B3, and B4. Standard deviation and RMSE values are almost same for all the DWT supplied. Corflet is having the lowest spectral angular mapping values, and also having the lowest gas values. So comparing all these matrices for this specific data set that we have used, Corflet is found to be being a multi-resolution analysis technique for the pan-sharpening of Landsat data. These are my references. Thank you.
It is fine. No question from my side.
Okay.
In your work, Aparna, in your work, means you should compare your method with some published one, na?
Yes, sir. We should be comparing that. This is like a very preliminary work that I've started. I've expanded this work to something more. So in that paper, not in that paper, in that work, actually, I've compared that with all the existing methods. There has been a chart which is done, not in this one specifically. So that has been comparison, because also there is a problem with a different data set, because on papers related to this one, it varies geographically, right? So maybe one paper.
See what happens in this specific type of work. You collect the data set, okay, and then you apply the previous methods, implement those methods, and collect the results, and then you test your proposed method.
Okay.
Okay. Data set is not a problem in this case.
Yes, sir.
Right.
Yes, sir.
You mean
Yes, sir.
whatever available you can use, and on that data set you compare all the your method and the previously method.
Yes, sir.
And DWT approach is very old actually. Now I think there are some advanced geometrical transforms are available like contourlet, curvelet. So pen sharpening based on this is, I think it will give much better results than DWT.
Sir, yes, sir. Sorry, sir. Can I talk?
Yes.
Works are based on those advanced wavelets. So that process is going on. So in that phase, I'm just adding that. This is just a preliminary work to what I'm doing.
Okay.
Questions from myself.
Next presentation, paper ID 461, Ms. Aarti Anuragi.
Okay, thank you.
So is my slide visible?
Yes, ma'am, it is visible. Turn on slideshow. Yes, you can start.
Good afternoon, one and all present here. Today, I, Aarti Anuragi, going to present my research work on topic performance evaluation of TWT, TQWT, and EMD for automated major depressive disorder detection using EEG signals. My paper ID is 461. I'm from the Department of Computer Science and Engineering, National Institute of Technology, Raipur. Presentation where first I will go through the background of the research work, literature survey, problem description, methodologies, result and discussion, conclusion, and
Your slide is not visible. I hope there is some technical issue.
Yes, sir. Yes, sir. She will be joining in a moment. She had some network issue.
sorry for the interruption, sir. Hello, sir.
Yeah,
is
you
my
can
slides
continue,
visible?
please. Continue,
Yes.
please.
Yes, sir. The first treatment which the physician advised for the major depressive disorder is an antidepressant pills. But we have seen only 1/3% of the people are responding to this type of treatments. So EEG signal is preferred more due to its flexibility, low cost of effectiveness, and good temporal resolution for analyzing such kind of signals. EEG signals is nothing but it is a non-invasive test that is that records electrical patterns in the brain, and it is useful for diagnosing various brain disorder diseases such as epilepsy, seizures, brain injuries, headaches, brain tumors, sleeping problems, etc. These are my few literature surveys which has been they have worked on detecting depression using EEG signals, where the first proposed method has used discrete wavelet transform for analyzing EEG signals with various non-linear features, and they have achieved 98.11% of accuracy with 11 features. Like similar work, the next one has also done, where they have compared the linear and non-linear feature extraction methods, and then achieved they have achieved the accuracy of 90% with non-linear features. The Acharya sir's team has developed an depression detection system using one DCNN network and achieved the maximum accuracy of 96.0% and 93.5% from the right and left hemisphere, respectively. Though there are various research has been conducted for developing the depressive detection system using EEG signal, but there's still possibility for improving the system classification performance. So here we have proposed an method, automatic automatic depression detection system method using EEG signals in this study. This is the block diagram of our proposed method, where first of all, we will acquire the EEG signals and preprocess it. Then afterwards, for analyzing the EEG signals, we have comparatively analyzed two different wavelet transform, that is TunQ wavelet transform and empirical mode decomposition method. After that, after extracting the subbands from these two methods, we have extracted non-linear features from them, and then we have significant test has been applied for evaluating the effectiveness, evaluating the ability of features discrimination. After that, classification is performed for classifying the performance of the model. So each and every step I will explain in this next slides. So first of all, I will explain the description of EEG signals which I have taken in this experiment. The publicly available EEG database provided by the Mumtaz team from the Hospital of St. Wales, Malaysia, has been studied in this experiments. Here, two sets of data has been taken. The depressive patients are 34 patients were taken from depressive disorders, and 30 patients have been 13 EEG signals have been taken from the healthy EEG subjects. Now we have also shown in the table the ratio of the male and female from where the signals has been extracted. We can see that depressive patients we have equally extracted the EEG signals, whereas in healthy subjects we have taken 9 subjects females and 21 subjects from male sides. Now the sampling rate of our signals are 256 Hertz. The duration of EEG signal recording was 5 minutes from each signals. Here we have extracted from 9. Here they have extracted EEG signals from 19 channels. From in figure 2, I have depicted the sample of depressive signals, whereas in healthy patient signals of 5 seconds. Yeah, 5 seconds. Yeah. Then the one method, that is TQWT method, is an adaptive method which is used to represent the time amplitude signal into a time frequency representation of EEG signals, which encapsulate the set of wavelet coefficients. So here it is very flexible, tunable factor, which it depends upon the 3 parameters, that is quality factor, maximum number of subband signals, and redundancy parameters. So in this experiment, I have taken the values of these 3 parameters as 3, 7, and 3, where the subband signals will be extracting with J+1, that is here we have extracted 8 subband signals from each signal. The figure 3 is showing the decomposed subband signals from channel A2, A1 from healthy and depressive EEG signals. Now the next wavelet transform was we have used was empirical mode decomposition method, where from this again we have extracted the 6 EEG signals, decomposed EEG signals. So after extracting the signals, we have extracted non-linear features. The non-linear features such as log energy entropy, approximate entropy, sample entropy, Rhian's entropy, mobility, complexity, and fluctuating index. All these features measure the invariability in presence in the EEG signals. Now, a total number of features were 56 features were extracted from TQWT and 42 features were extracted from EMD. Now, after extracting these features, we have selected the most significant features using the student t-test method, where the alpha value has been put as in 0.005. The lesser value signifies that the features are significant, and greater values signifies the features are non-significant. So table 1 depicts all the p-value of all the p-values of channel A to A1 from TQWT method. I have highlighted the non-significant features in the red color, which is discarded from this experiments. So this is the class. So for classification purpose, I have used the three classifiers, that is ensemble, that is decision tree classified, KNN, and SPM. So evaluation is taking place between these three classifiers, and I have also shown the number of features which which provides the maximum accuracy. So we can here I have evaluated individual channels as there were 19 channels required for each signal. So I have evaluated individually. Now we can see that in individual channel using EMD, the mostly accuracy comes around 94. But using TQWT, it comes around 97% accuracy. But the features increases around 50, and here EMD the features are around 90. So for further improving the performance, we have merged the accuracy from top selected top performing channels. So below roses, it is shown that after merging the features, the performance of the model goes on increasing. So I have highlighted with the red color the highest performing channels with the merging channels. That is with 146 features, we have got 99.2% of accuracy. These features are still very large, so I have applied the feature selection method for in that. So I have applied 4 feature ranking methods, that are entropy feature ranking, ROC, Bhattacharya's, and Wilkinson's feature ranking method. So this figure 3, shows different various numbers of features with different feature methods. So we can see that 70 features, we have attained maximum accuracy of 99.3% of accuracy. Similarly, with this model only, the ROC plot is shown in figure 4. This is the comparative analysis of our proposed method with other state-of-art methods, where we can see that they have considered different duration of recording signals. Like most of them have used the full recording signals, that is 3 seconds, 5 seconds, 5 minutes, etc. But we have used the less number of seconds and achieve the highest percent of accuracy. That is, we have used 5 seconds of EEG signals, achieved 99.30% accuracy with only 3 channels. So we can conclude that the proposed method achieves more than 95% of accuracy from all the 20 EEG signals, obtain the highest classification accuracy with 99.30% with 3 channel with 70% 70 features using TQWT from ensemble classifiers. In future, this proposed method can be used for detecting various disorders like focal emotions, sleep disorders. These are my references which I have used in the this PPT. Thank you so much. Any queries?
Thank you, Arti. It's a nice presentation, and you have covered almost many techniques in this particular presentation. And you know that major depressive disorder is a very common at this moment.
Yes, sir.
And it's a very good topic that you have chosen, and I hope your mentor will guide you in such a way that you will get a clear-cut and comprehensive understanding between the major depressive disorder. Again, means when you are using the major, the term is very serious. Means
yes, sir, yes.
Different than the Okay, so the normal depressive disorder and the major depressive disorder is a different thing. So that's why it's a very interesting work that you have planned, and it's a well planned, and I hope in future you will be able to show us the some good result from this your database. So it's a nice understanding. Thank you. Thank you.
Thank you so much, sir.
Any other questions from session chairs?
No questions, sir. It's fine.
Okay, that was the last presentation of the session. On behalf of NIT Raipur and organizing committee of the conference, I thank you all for sparing valuable time as well as providing valuable insights to the authors. All the session chairs are kindly requested to fill the evaluation sheet so that the best paper award can be decided and finalized. So the Google form links for these evaluation sheets were already shared in email to the respective session chairs. So thank you all for joining. The keynote session is going on. You may join the keynote session. The link is already being provided in the chat box. You can use the link to join the keynote session. Thank you, everyone. Thank you so much.